Hello and welcome to my channel. This is for CHEM 103, so if you're in a different class that I teach, you're in the wrong place. This is the lecture for prerequisite science skills. It is the first lecture that you need to watch. So if this is the very beginning of the semester, again, you're in the right place. Just to give you a little bit of a heads up, these pre-recorded lectures are not the end-all be-all. There's also live lecture components, so make sure that you tune in each week at the time for your section so that you can do practice problems, get the latest information on homework assignments, exams, all that good stuff. These pre-recorded lectures are just another venue for you to get information, for you to be able to sit down and take notes at your own leisure, at your own pace. You can rewatch the videos, that kind of thing. This will give you the concepts that you need to do the practice problems that we're going to do in class. We'll also go over big concepts, things that I think maybe need to be retaught, make sure that we're all on the same page in the live lecture. So live lecture will have a lecture component, but there will be a lot of practice problems, and it'll be a space for you to ask questions more so than me just reteaching the material. There will be some times when we're just going to teach. I'm sure we'll get to those sooner rather than later in the semester because I understand how things work. You may not always have time to watch this lecture before going to class. With that said, let's get started. The first topic we're going to cover is measurements. If you've ever done any kind of a lab work, if you've done cooking even, I consider the kitchen a lab. You're taking measurements. In the kitchen, you're measuring liquids, you're measuring flour, so solids and things that you're going to mix together, right? In the lab, you're measuring all your reagents, which may be liquids, they may be solids, and you need to use instruments to get those measurements. So all a measurement is something that is acquired using an instrument. Every instrument that gives you a measurement has a certain degree of inexactness, which I know is a little bit of a funky word. And we call that uncertainty. What that means is, how many ticks do I have on this ruler? Or how many decimal places do I see on the scale? In this case, I've got two clocks here. So clocks, not exactly scientific instruments, but I think that it gives you that visual of, okay, if I had to tell time with an analog clock, which nobody really does these days anymore, which one would I rather use? This one on the left here, it's got all the numbers, but it doesn't have any tick marks in between. So if it's not exactly on a number, I'm guessing. So I can tell you it's for sure 12 o'clock or 1 o'clock or 3 o'clock. But as far as the minutes go, I'm like, well, maybe it's 3:02, maybe it's 3:04. Can't really tell you for certain. So the hours, totally know that. Boom. But the minutes, that's kind of questionable. However, this clock on the right, I've got tick marks in between each of these numbers. So I can tell you that it is 10:02. I can tell you it's 11:37. And that's a lot easier for me because I can see it. There's also this red second hand. So I can tell you minutes and I can tell you seconds. If we're relating this to uncertainty, the clock on the left is the most uncertain. It's the one that gives you the least information. Conversely, the clock on the right is the most certain. So there's two different ways you can say this. I can ask you two different questions. Which one is the most uncertain? which one is the most certain. So make sure that when you're doing your homework, when you're doing your chapter check-ins, always read the question. The most certain one gives you the most information. And oftentimes this information will be in the number of decimal points that you can read from whatever instrument. So the most decimal places will come from the most certain instrument. The 3 types of measurements we'll be talking about in this course are length, mass, and volume. An example of a length measurement would be the centimeter, mass measurements, the gram, volume measurements, milliliters. So we use the metric system for this class. We will refer to the imperial system, which is the system that we use if you're thinking about how we measure liquids and stuff like that. Cups, ounces, that type of thing. We'll refer to those types of measurements, but by and large, we will be dealing with the metric system. In the next chapter, we'll talk about the metric system, how it works, how to do conversions, that kind of thing. But for now, just know that this is the system we're going to use. Each measurement has a certain number of significant digits. And these significant digits are just all the numbers in a recorded measurement. I will call these sig figs because they are also sometimes called significant figures. When I learned this many moons ago, it was significant figures. Now we're saying digits, same difference. So if you see me say, you're not going to see me say anything. This is a remote class. If you hear me say sig figs, or you see the term sig figs written down, or SF, that means significant figures, which is the same thing as significant digits. Okay. Now with that out of the way, sig figs include all the values of the known that you can know for sure, plus one uncertain digit. So if you have a scale with your little digital display, right? Let's say that display said something like 1.234 grams. Now, right, this is a scale. This last digit is the uncertain digit. And if you've ever used a scale or balance, you'll see that last digit kind of fluctuates. It might go down to 2, it might go up to 5. It kind of floats around a little bit before it settles. That's the uncertain digit. All these other numbers are known with certainty. We know absolutely 1.23. We're kind of guesstimating the last digit. So each measurement has one uncertain digit at the very end. The easiest way that you can visualize this is with length measurements. So we're going to go through kind of a practice example talking about how to read the length from a ruler and take into account the number of significant figures you're supposed to have based on the markings on the ruler. And then we're going to determine which ruler has more uncertainty. If you would like, you can pause now and try it yourself and then you can keep watching the video and see how you do. Otherwise, I ain't gonna hold you if you want to just watch the video, take it in, and then at the live lecture, you can do what it do. All right. So let's look at these two rulers. We've got ruler A and ruler B. We're measuring the length of a metallic rectangular solid. Right off the bat, when we're talking about certainty, we're talking about how many tick marks are there, how many decimal places can I get in a measurement. Ruler A, we only know the centimeters, 0, 1, 2, 3, 4, 5. With ruler B, there are tick marks here. So that means that we can read something that is a little bit more, it's got a little bit more certainty to it. So as far as which ruler has more uncertainty, that's going to be ruler A. Doesn't have as many tick marks, so when you're making your measurement, you're not really going to be able to tell much past, all right, I see 4, right? So I know it's 4 point something. Remember, each measurement has to have one uncertain digit, and that uncertain digit is the one that you guesstimate. So if I'm looking at ruler A, I'm going to say, well, this might be about 4.5, so maybe this is about 4.3. That's your uncertain digit. With ruler B, we've got centimeters, and these little tick marks are millimeters. So that means that we can say with certainty that we've got 4.2. And now I'm guessing this last digit, and it's somewhere between the second tick mark and the third tick mark. I'm just going to call it 4.25 centimeters, where that 5 is my uncertain digit. So notice the difference here. We've got 2 sig figs from ruler A and 3 sig figs from ruler B. We'll do a little bit more practice in class, but I just want you to take a moment and make sure you see the difference between the two rulers and why ruler A is more uncertain. The other way to say it would be ruler B is more certain. So make sure you're familiar with that and you're comfortable with those terms. So I mentioned mass, sort of, when we were talking about sig figs and uncertain digits. Mass measurements, we're just using a scale or a balance, and you're measuring the amount of mass, or it's the amount of matter that something contains, excuse me. You use a balance, it's not affected by gravity. For volume measurements, you're looking at the amount of space that's occupied by matter. You can use a whole bunch of different tools to measure volume, from a graduated cylinder to a syringe, lots of things you can use in the lab. When we get these measurements, whether they're volume, length, mass, we're usually going to do some kind of calculation. In order to report our answer with the correct number of significant figures, we have to know how to count the number of sig figs in a given measurement. So here's how we do this. If you have a measurement, you're going to start counting the number of digits from left to right, starting with the first non-zero digit. So let's do this first example here. The first non-zero digit is 9, okay? So this is where we start. And then we count how many non-zero digits we have, and we count all of these significant zeros. We've got 2 sig figs here, the 9 and the 7. These zeros in front of the 9 are placeholder zeros. If I took away those zeros, I'd have a different number. But I'm not measuring those zeros. I'm just using them to show you that I mean 0.097, not 0.97. Those are 2 different numbers. Now let's do this next example. 1.907 milliliters. We're going to find that first non-zero digit starting from the left. That's the 1. Then we're going to count everything that comes after it for a total of 4 sig figs. This 0 is significant. That means that it's measured. Those measured zeros are kind of sandwiched in between other numbers. There's also cases where significant zeros can be at the end of a number. I'll talk about that in just a second. But in this example, you see a 0. It's sandwiched between 2 non-zero numbers. So it is absolutely significant, and you should count it when you're counting the number of sig figs in this measurement. Our last number, 1970 centimeters. We've got our first non-zero digit is the 1. Then we've got the 9, the 7, and we've got a 0 after it. This number only has 3 sig figs. This last 0 is a placeholder. If it wasn't there, we would have a different number. How do I take this number and represent it as 4 significant figures versus 3? So let me rewrite. That's 3 sig figs. By adding a decimal point, I'm now saying this 0 is measured. So that means I'm going to include the 0 in my counting. Now let's add another complication, because these zeros will get you. Let's say I added another 0 after the decimal point. We'd be adding another significant figure. So I want you to see the difference between 3, 4, and 5 sig figs when it's the same number. We will do practice for this in class. The placeholder zeros will try to come for you. Don't let them. We'll practice. Make sure you ask questions. Make sure you can tell the difference between a placeholder 0 and a significant 0. Now we talked about measurements. It's something that you're looking at an instrument, you're recording a number. There are also exact numbers. For exact numbers, there are no significant figures. There's infinite number of significant figures because we know for certain what we're looking at. So the example here, we know that there are 7 quarters in this image here. We can count them. We don't have to try to guess, oh, maybe there's a third of a quarter. No, you either have a quarter or you don't. For exact numbers, you can count them. Oftentimes, it's a number that you're able to count. There will be times where we have an exact number that is, some kind of figure we use in a calculation that we call an exact number. But for this chapter, we're really just talking about things that you can count versus things that are measured. You can count how many coins there are. You can count how many balls there are. You can count, how many penguins are in the zoo. However, if you're trying to take a measurement, you're trying to take the mass of a penguin, then that's going to be a measurement with significant figures. Why are you trying to weigh the penguin? I don't know. But if you did, it would be a measurement with sig figs. You'll need to know the difference between these two. So I'm giving you very silly examples. Hopefully that will help make it stick. So this is an opportunity for you to check your understanding. I encourage you to pause here and give these a try. If you don't, I ain't gonna hold you. Make sure that you tune in to the live lecture and you do the practice problems with me, participate, and that will be great help for you. So now we have to identify each number as a measurement or exact number. And if it's a measurement, we need to say how many sig figs there are. So in this first one, we've got 460 grams of flour. I see grams. That's what that G is. That tells me it's a measurement. I'm going to put an M. 0.250 pounds of butter. That's what the LB is. Again, we've got a unit here, pounds. That is a weight. Measurement. 10 chocolate chips. Chocolate chips are not any unit of measure that I know. So it is exact. And I was clearly thinking about chocolate chip cookies when I wrote this. I apologize if you're hungry. But I was hungry too. So have a cookie after you're done. You've earned it. How many significant figures are in each measurement? Now we got to deal with these pesky placeholder zeros. In the first measurement, 460 grams of flour, our first non-zero digit is the 4. We're going to count the 4. We're going to count the 6. But that 0 at the end, that's a placeholder. I'm going to put PH for that, placeholder. So we've only got 2 sig figs here. With the butter, our first non-zero digit is the 2. We are after the decimal point. So we're going to count all of the numbers that come after the decimal point as significant. And this is the example I was talking about earlier. When you have a 0 that comes at the end of a number with a decimal in it, that means everything is going to be significant. So this number has 3 sig figs. The third one is an exact number. So we don't need to do any sig figs. We know for sure there's 10 chocolate chips. And if I eat 3 of them when you're not looking, then you're going to have 7. You can count it. Again, we'll do practice. So make sure that you're comfortable with this because it'll show up on an exam that you will have in the future. Like I said before, we take measurements, but we don't just stop there. We do calculations. When we do those calculations, we generate a lot of non-significant digits. So let's say you're doing a calculation and you get this really long number. Don't give me this number. Now you can't see me, but I am emphatically pointing here. Don't give me this number. It will make me sad. It will make me frustrated. Don't give me 12 decimal places. Those are not significant. We have to have rules for rounding off non-significant digits so that you don't make Dr. Hefner sit in the corner and cry. If the first non-significant digit in a number is less than 5, then you drop all the non-significant digits. So let's use an example. Let's say that we have this number of grams, and we need to round off here. Okay, so we're trying to stop here after 1 decimal place. I'm going to look to the number that's directly to the right of the one I'm interested in rounding. There's a 3 there. 3 is less than 0. So my number, I'm going to drop the 3 and the 2. And that's going to be 14.5. Should have written the question up here because that would have been helpful, right? So we're trying to round to 3 sig figs. And that's just an arbitrary number. Let's do another one. We're going to use the same number, but this time we want to round it 2 sig figs. 1, 2. So that means we're keeping the 1 and the 4, and we're looking to the next number. If the number next to that digit you're trying to keep is 5 or greater, then you're going to increase your last significant digit by 1 and drop all non-significant digits. 4 goes to a 5. So you have 15. Let's do a couple more examples. I know I have more coming up, but I want to make sure that we get it. Let's say I want to report this number with 3 sig figs and with 2 sig figs. With 3 sig figs, and I'll use a different color, we've got 1, 2, 3. That's the third significant digit. We're going to look to the number directly to the right. It's a 2. It's less than 5. So we're not going to use it. We're going to drop it. But 189 is different from 1,892. We did a little bit more than just rounding there. So we need to add a placeholder 0. This number has 3 significant figures, and we use that 0 to show the difference between 189 and 1,890. And think about it. If I told you I was going to give you $1,890, and I put $189 in your hand, you might still be grateful, but you'd be like, so where's the rest? Always make sure that you add a placeholder 0 when you're doing this kind of rounding, because those two numbers, 189 and 1,890, two very different numbers. Now let's do the second example. We need to do 2 sig figs here. 2 sig figs would be the 1 and the 8. I'm going to be looking at the digit next to the 8, which is a 9. It's bigger than 5. So that means that 8 is going to become a 9. And we add 2 placeholder zeros. Because again, 19 versus 1900, very different. Again, we'll practice. The placeholder zeros really will try to come for you though. Don't let them. And I just gave you all that information and wrote over my last point. But it's okay. We're going to go over it anyway. If you have to do a calculation with several multiplication or division operations, do all those operations first and then round at the end. So here's some more practice and more placeholder 0 practice. Round this measurement to 2 significant digits. Let's figure out, first off, how many significant digits are here. 1, 2, 3, 4, 5. This measurement has 5 sig figs in it. We need 2. The 8 is the second significant digit. So that means we need to look at the 4. Then we determine if we round up or just drop everything off. 4 is less than 5. So everything's going to drop off. But 48, very different from 48,000 something. We need some placeholder zeros. Let's do some more practice. This is going to take into account reading the ruler and knowing how many significant figures you should have from the measurement, and then rounding that answer to 2 significant figures. So what is the length of the blue line in centimeters? We've got, for sure, 4 point something, 4.9, because we can read that just using the tick marks. Now we need to do our uncertain digit, which comes at the end, kind of guesstimating what this last digit is. I'll call it a 5. So that's my guesstimated, or my uncertain digit. Guesstimate is not exactly a scientific term, but y'all know what I mean. Now we've got to take this answer and round to 2 significant figures. Currently, we have 3 sig figs. We've got to change that to 2. This 9 is what we're looking at to whether we need to round up or keep it the same. Next to it is a 5. 5 or greater, we're going to round up. But after 9, what do? For this measurement, to give two significant figures, we have to write 5.0 centimeters. So this is one of those kind of strange ones where we actually ended up having to change the 4 to a 5 and change the 9 to a 0. That's the only way that we can increase this number to round to two significant digits. Again, we'll do more practice. If your brain hurts, I apologize. You can always take a break. When we're doing calculations with measurements, there are rules to make sure that we retain the number of significant figures that represents the least amount of certainty that we have. So when you're adding and subtracting, your answer is limited by the value that has the most uncertainty. What does that mean? The one that has the fewest decimal places is going to be the one that is the most uncertain. So the question is, which one of these has the fewest decimal places? I'll give you a second. Top number, middle number, bottom number. Fewest decimal places, meaning places after the decimal point. If you guess this one, you win the prize of being knowledgeable. Can't really give you anything. What I like to do when I'm adding or subtracting is draw a dotted line that shows me at the end of this, where do I need to round? So you're going to add your numbers together. You can use a calculator if you want. I'm going to do it old school. And we're talking about grams. Now this dotted line shows me, okay, the last digit that I can retain in this number when I'm writing my answer is the 6. And the digit that's directly to the right of this dotted line is what I need to use to determine if I'm rounding up or just dropping off. Next to the 6 is a 3. It's less than 5, so I'm just dropping everything off. That's my answer. When you're multiplying or dividing, we're looking at the value with the fewest significant figures. So that means you have to count sig figs, do your calculation, and then report your answer using the number of sig figs that represents the fewest number of sig figs in the measurement. So we're given a problem where we've got 7.28 centimeters times 4.6 centimeters. Well, our calculator is going to give us lots of decimal places. But our measurements have 3 sig figs and 2 sig figs respectively. This calculator answer, however, has 5 sig figs. Not allowed. We need to round to 2. Because our measurement, the measurement with the fewest sig figs, has 2 sig figs in it. We're looking at the 3. That's the last number we're going to keep. We look at the 4 next to it. Well, looks like we're just going to drop everything off. So that is how you do multiplying or dividing. also keep in mind, when you're multiplying and dividing measurements, you're also multiplying and dividing their units. So centimeters times centimeters is centimeters squared. The way that you can remember this is if you have 2 times 2, that's equal to 2 squared, right? Well, centimeters times centimeters is centimeters squared. Same thing for division. If you're dividing a number by another, you can also divide your units, and we'll do some examples of that. That'll be something we do in class because it's a little tricky. So it's harder to do with a pre-recorded lecture. But make sure that you tune in for the live lecture and participate so that you get it. You will see it in your homework. All right. Reporting sig figs after multiple operations. This is key because most of the time you're going to do more than just add or subtract or divide. You identify the measurement in the problem with the fewest sig figs. Okay. You do all your calculations, mumbo jumbo, all the typing on the calculator, Then you report your answer with the same number of sig figs as that most uncertain measurement. So the one that has the fewest sig figs. So let's do an example. You can try this if you would like. So pause it, do it, or you can just watch me do it. And then if you have questions about it, you can ask in class. Let's say you have 3 boxes that all have the same dimensions. What is the combined volume of all 3 boxes? As a reminder, you probably know this intuitively, but length times width times height, that's volume. If we're talking about, a solid of some kind. We've got 3 of these suckers. So the combined volume is going to be 3 times our length times our width times our height. We've got 3 different measurements, length measurements. 3.5 centimeters, 5 centimeters, and 10 centimeters. 3.5 centimeters has 2 sig figs. 5 centimeters only has 1 sig fig. And now we get to the 10 with those doggone zeros. We know it has at least 1 sig fig. Does it have 1 or 2? Well, 1 is very different from 10. We don't see a decimal point at the end to tell us that 0 is measured. So that means we've only got 1 significant figure there. When we do our calculation for volume, we need to report our answer with only 1 sig fig. Punch it all into your calculator. And your calculator is going to tell you a number. It's not even going to tell you units, okay? We know that since we're multiplying centimeters times centimeters times centimeters, that it should be centimeters cubed. Do not forget your units. When we start doing, real math and like solving problems, I will take points off if you don't have units. So that's why I'm harping on it now. But our calculator answer has 3 significant figures. We're only supposed to have 1. If we're going to round this, that means that we're looking at that 5 and saying, you stay. Let's figure out if we round you up or you stay the same. The number next to the 5 is a 2. So we're going to add 2 placeholder zeros. And that will be our answer. Don't worry, we'll practice. I hear you worrying. May not be all of you, but I hear you worrying. Don't. It'll be okay. Now that we're on the train of talking about numbers, and we've talked a little bit about units and how we can multiply and divide units, now we're in exponents. And this is where it will become clear when I put that, the 2 or the 3 that's raised up kind of above everything else. That's an exponent. And that just shows you that a number has been multiplied by itself. Our 2 times 2 example, 2 squared, right? And to remind you again, with units, centimeters times centimeters, that's centimeters squared. So it can be a unit that is multiplied by itself. You've got an exponent there. We've also got powers of 10, and we're building something here. We're building to a concept. So don't let those exponents leave your brain. A power of 10 is a number that results when 10 is raised to an exponential power. So that can be positive or negative. So 10 to the second power is 10 times 10, right? That's 100. 10 to the negative 2, well, that's a negative number, so we're going to actually get something less than 1. It's all about the decimal place. If you're unsure of exponents with positive and negative, this chart might be handy just so that you can kind of see what it looks like. The examples that we did are here. So it gives you a good representation of what it looks like. So 1 times 10 to the 2, again, is 10 times 10. 10 to the minus 2, you can think of as 1 over 10 times 1 over 10, which is 0.01. In science, you often have very, very big numbers and very, very small numbers. And nobody has time to be writing out 20 zeros. Instead of doing that, we use scientific notation. You represent your significant digits, and you use a power of 10 to show how many zeros and where. So example of scientific notation would be this. You've got your significant digits, and you've got your power of 10. So that's the format, what it looks like. Let's try to take an ordinary number and express it in scientific notation. We've got a really, really big number. We don't want to write all these zeros out. When you see a really, really big number, any number that's greater than 1, remember that there's kind of an implied decimal point. So for sig fig purposes, we've got 3 sig figs. But we know the end of the number is over here, which is where you would put a decimal point. The first thing you have to do is figure out how to represent your sig figs as your coefficient. We're going to take this decimal and plop it right here. Because we need our coefficient to be at least 1 less than 10. So there's our coefficient. We've got all the significant figures that we're worried about. Now we've got to figure out our n. That's the exponent. What power of 10 do we need to multiply our coefficient by to get this really big number that we've got before us? That involves counting back decimal places to get to where that decimal used to be. We saw, okay, we've got a decimal point at the end. We moved it all the way up here so we can get our coefficient. Now we've got to count our way back to where the decimal should be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 decimal places. But we've still got a decision to make because that n can be positive or negative. Our number is much greater than 1. That means your n is going to be a positive number. So that's the rule. You also may have heard if you move your decimal point to the left, then you have a positive n. Same thing. But in my opinion, saying, hey, this number that I started with is bigger than 1, it's going to be a positive n, is easier to remember and easier to keep straight in your mind when you're doing a test or something like that. Now let's do another one that's in the opposite direction. We've got the length between carbon and oxygen atom in a molecule of carbon dioxide is this really small number of meters. And we've got to write it in scientific notation. Remember that form we've got to make our coefficient, and then we have to figure out our n. The significant figures here, we've got 3 sig figs, and they're all at the end here, okay? I'm going to take that decimal point and move it here. That way, I have a coefficient that's at least 1. Whoops. There's our coefficient. Now I've got to count back to where the decimal point is. 1, 2, 3, 4, 5, 6, 7. But we're not done. We need to figure out if this n is positive or negative. This number is much smaller than 1. So n is going to be negative. Now we're done. So these are the rules that I kind of went through by giving you 2 examples. But I know that some folks need the rules written out, not just an example done. So, applying scientific notation. You place the decimal after the first non-zero digit in the number, followed by the remaining sig figs. Then you indicate how many places the decimal has been moved using the power of 10. Positive power means that you move the decimal point to the left. Negative power, you move the decimal point to the right. We'll do some practice on this. So if you're looking at it like, not sure I get that, don't worry, you will. For this course, you're going to need a scientific calculator. Doesn't have to be a graphing calculator, just has to be scientific. Scientific calculator you can pick up from Wally World, Target, $20. You can also borrow one from a friend who has taken this course or a math course before you. But make sure that you have one. When you have that scientific calculator, you're going to be entering scientific notation. You will need to know how to do that for your specific calculator. I am not tech support. I've encountered a fair number of calculators. I may be able to help you just by looking at it. However, for the best results, you should ask Uncle Google, look up your calculator, and see how to enter scientific notation. And also, make sure that you can read scientific notation from your calculator. Oftentimes, you're going to see an exponent key, EXP, somewhere. This is the little Windows calculator, but that's the EXP there. When you're entering a number in scientific notation, you will use that key. If your calculator is displaying something like this, where you see this little E here, that means that it's giving you scientific notation. So make sure that you can identify what that is on your calculator and what that looks like. That's all for the prerequisite science skills. Make sure that you tune in for the live lecture for your section. We'll do practice problems and we'll go over details regarding assignments and exams and all that stuff. Thanks for watching. Feel free to share if you know somebody else on the struggle bus taking chemistry. Here to help. Have a good one. Stay safe.